This problem says the function f of x is given below, and on the same set of axes, we're going to sketch the graph of g of x, which is a list of transformations of the original graph f here. All right, so what I like to do when I do this, and there's, again, a variety of ways to do it. I'm just going to show you one way, is to take into consideration all the transformations that are happening here on f and do those transformations point by point on the graph of g. So first of all, I'm going to say start from the inside and look at the transformations as you move towards the outside. Like order of operations, you do parentheses first. So start with this guy. So this x plus 1 here means that you're going to move left 1 unit. This negative sign here is a reflection over the y-axis. Then I put that number into f and evaluate it, and then I take 1/2 of it. So this is 1/2 of an output. So that's going to be a vertical shrink. Next. And then I'm going to go down 3 units. Well, this is a vertical shrink by 1/2. I better put that in there so I remember. Okay? So we're going to take each of these points individually, and we're going to move them. Those 4 transformations. So I start here with my point -3, 7 approximately. So this point has to move over to the left 1 unit, which is now -4, 7. I reflect it over the y-axis, which puts it at +4, 7. And then I have to shrink the output vertically by 1/2. So 7 divided by 1/2 is 3.5. So here's 3.5. And so approximately right here. And then from here I go down 3 units. Well, I'm up at 3.5 already. Okay. So down 3 units would put me at just at 1/2 above the axis. So this is the final point where this guy rests at 4 1/2. Let's do this guy here. So I'm going to go left 1 unit, which puts it at -2. This is -1, 0, by the way. Go left, that puts it at -2, 0. I reflect it over the y-axis, that puts it at +2, 0. I vertical shrink by 1/2. Well, it's already on the axis. The output is 0, so it's not going to go anywhere because 0 times 1/2 is 0. And I go down 3 units, so I should end up at 2, -3. This point right here is 0, 1. So I'm going to move it to the left 1 unit. So it's at -1, 1. I'm going to reflect it over the axis. So that's going to be at 1, 1. I'm going to do a vertical shrink by 1/2. So it's going to be, if I'm at 1 now, I'm going to go down to 1/2. And then I have to go down 3 units. Now 3 units straight from the axis is right here. But I have to be 1/2 above that, so -2.5. There's my end point for 0, 1. Now this point right here is 1, 0. So I'm going to shift it 1 unit left, and a reflection over the y-axis, it doesn't move anywhere because it's on the y-axis. A vertical shrink by 1/2 doesn't move it anywhere because it's on the x-axis as well. And then I just go down 1, 2, 3 units. So the point 1, 0 ends up at 0, -3. Now this last point here is at 3, 7. So I have to move it the same way. Left 1 unit puts it at 2, 7. Then I have to reflect over the y-axis, so -2, 7. Right about here. Then I have to do vertical shrink by 1/2, so 7 divided by 2 brings me down to about 3.5 here. And then I have to shift down 3 units, so that'll leave me 1/2 unit above the axis. So you can see that your original graph has some sort of symmetry here, and so your final transformation should have symmetry as well. Because it's not like we're moving the points out of sync from the sink that they were in originally, for lack of anything. And now I don't mean like kitchen sink. I like synchronized sink. So what I'm going to do is connect the dots the same way they were connected originally. They're just going to look a little bit different because they're a different shape. So this is going to be a slight curve here, a hill here, and a slight parabolic curve-like shape there. So this graph is the graph of f of x, and now through all these transformations we get our graph of g of x.